And in this video, we're gonna basically look at some of the questions related to, or starting from this video, basically we're gonna start to look at questions that are commonly asked, that are categorized and can be solved with a basic knowledge of arrays. Okay, so first, I want to talk about all these questions, the interview questions that are asked. So most of the time, what you may find that these interview questions that have been asked, and if they're array related, um, first, how can you find out, like, if they are, like, related to arrays, or is there any particular algorithm or data structure, like stack list, linked list, hash, any of these needs to be applied? Well, the best way to find out what kind of question it is to closely observe and read the question slowly and try to understand, is there any special situation that you're going to need that your arrays or particular data structure that you have in mind does not cover that. Okay, and once you actually understand, the question where it belongs, you're gonna actually know how to solve that and or how to approach about solving it, um, like in on the whiteboard, or if you're some companies actually do provide, a quarter pad or something, so you can in a whiteboard or in a quarter pad. So the key is to read the question slowly, read it carefully, ask any questions, any doubt you have. Like, is there, an array? For example, you were given a question that there is an array and you want to count, it's a binary array, and you want to count consecutive ones. Now, you know, ask question whether the array length matters. So if the array is empty, what do you do? Does array will array contain all zeros, all ones? Will it contain, basically, will it all only be one or zero because it's a binary array, or it's going to be just an array? And all after like asking all these different kind of questions, these are just some examples, but after asking all these questions, your interviewer may actually hint to you what kind of things, I mean, where you're headed. So and remember, interviewer is there not to grill you on these things, but to help you approach that problem, because what they're really looking for is for a candidate where they can work with the candidate to solve that problem. In most of the cases, when interviewers are taking these interviews, yes, they know the solution, but that's part of the strategy, because they are required to come in and be the part of the process, not just be the spectator. So they're there to help you, not just to judge you on your programming skills. And this, by far, is common for most of the tech companies. If you see, it different, that clearly indicates different intentions. And people have different personalities to present, but most of the time when the big tech companies, they actually train their interviewers, they keep this notion in mind, where they say that you are there uh, in the room for candidate to help him out to basically achieve that solution, and you're not there to actually fail them, but you're there to help them succeed. That's what the collaboration is all about, because at the end of the day, you won't believe it, but it's really hard to find good candidates. And most of the time, for that reason, the company understands that if they become the part of the solution and help candidate achieve the solution with the right strategy, not giving you by hand. So they give you, most of the time to think. They give you, directions, but they don't give you solutions, because they want to test your problem solving skills, but they also want to test your personality, how you're going to go work in a team. So those are all things, you have to keep in mind walking into the interview. So I just wanted to talk about this, right in the first questions video before we actually jump on it, because it is actually important to understand the intentions of the interviewer, and then go with the positive attitude into the interview. Okay, with that said, let's go ahead and take a look at what we have for the questions. Okay, so first question is coming straight from the example that we used. And the question is very straightforward. It's basically finding maximum consecutive ones. Okay, maximum consecutive number one in an array. Okay, so the question simply states that given a binary array, now this is the key, it's a binary array. That means it's always going to have one or zero. Okay, so if your interviewer says, hey, you have an array and you have to find consecutive ones, you can ask this. If they don't specify that's the binary array, you can ask this as a follow-up question, that will the array have any other number other than zero? Basically, will it be like, one or zero? The solution that we're going to come up with is not going to matter for us, but it actually helps clarify. It helps you basically build that solution, and it helps you. Asking these questions helps you basically get to that point of understanding what kind of problem it is and what you're going to actually need to solve it. Okay, so continuing on. Given a binary array, find the maximum number of consecutive ones in this array. So once again, what we need to do is we have an array of ones and zeros, and we need to find maximum number of consecutive ones. So that means ones that are coming one after the other. So they're consecutive in a row, and the chain is not breaking. For example, if you take a look at this input, we have one and one. These two are consecutive to each other, and then zero. So that chain broke. Then you have 1, 1, 1. Okay, so in this case, the maximum consecutive ones is the count is basically 3. Why? Because if it was just this much array, 1, 1, 0, then it would have been 1, 1, that means just 2, and then chain breaks with 0. So your output would be 2. But your chain breaks right here. So far, if you start to think about the strategy that you're going to actually approach to solve it, you're up to this point, your maximum consecutive ones count is 2. Okay, 1 and 1, that's 2. Okay, then your chain breaks. So you got to restart. So you got to reset your counter, and you got to say, okay, I got another one, and so that means like this is like the new streak that I gotta consider. Okay, so the strategy that you're gonna actually go about is you want to remember what you have counted so far. Okay, so we are talking about like the hints that you're gonna get, like. I mean, these are not going to be exactly the hint that the interviewer is going to give you, but like you can ask these follow-up questions like hey, if this like this chain breaks, you want to find out like maximum consecutive ones. There's not much room. This is a really simple question to ask questions, but make sure like you're like crystal clear on what you're trying to approach. Okay, so then you go about and count like another streak of ones and say 1, 2, 3. Okay, this is maximum, so that's going to be my output. Okay, so once again, the explanation is like, first two digits and last three digits are consecutive ones, but maximum of these two is 3, so that's why our output is going to be 3. Now, take a break and basically pause the video here and think about the solution that you're going to put forward. And then I'll I'll actually wait just a minute for you to pause the video, and then I'm gonna actually talk about the solution. Okay, so let's talk about the solution that we're gonna basically that we're gonna put forward in this one. Okay, So the solution, once again, it goes back to what we just discussed. Okay, so I'm going to show you the pseudocode in a minute. Okay, so solution is could be like this. So we are counting one and one, and we are keeping track that this is two so far, and then we run into zero. Okay, so zero is basically the way to tell us that, hey, this is the maximum number of ones I have found so far. Now, you want to make sure you store it somewhere because you may run into another one and because your array is not over and you just want to do this in one for loop because you want to keep the time complexity simplest. Okay. I mean, the lowest possible, the fastest algorithm. So, you're gonna remember what you have found so far. Then you're gonna basically reset your something like a local counter. So you'd have a global counter and a local counter. So global counters keeps the number of ones that you have found so far, and then your local counter resets when it encounters zero. And then you go on and continue. So your local counter again increments to one, and then it increments to two, and then increments to three. Okay. Now at the end of every iteration, you compare your local and global counters to see which one has the maximum value, which one has the biggest value, and whatever the biggest value is, that's what you return at the end of your function. Okay. So if that's not clear, let's take a look at the pseudocode and it'll make it clear. So once again, think about looping over the array, keeping the maximum count that you have found so far with the current count of number ones. All right. So then you say, return int of max count, that's just function name. That's just a return type and find max. And you actually supply the input array. And then you keep two counters. You keep a local counter and a global counter. Both of them are initialized to zero. Then you go inside the loop. And so it's a for in loop. So for n in input array. So that item in input array if the item is equal to 1, okay, then you say local count is equal to local count plus 1. That means you increment 1 by 1. And then you say global count. Immediately after that, you check uh, basically global count and say max of local count and global count. Reason you want to do it in each and every step because you don't know when your local count is going to set to zero because this is forward looking loop. So it's going in one direction. So you don't know when it's going to end. So you don't want to wait. So you want to be really aggressive about checking when you need to actually decide to update your global count. So you do it immediately after updating your the value of your local count. Okay, so you do global count. You say maximum of local count and global count. So you so far you've got one, so you get one because global count value is zero and local count value is one. So maximum of these two is one. So global count stays one. Now you come to the second number, second one. So this one right here. And your local count increases to 2. Now your global count has 1. So that means your global count now becomes 2 because local count is maximum. Now you have 0. Okay. So when you encounter 0, your local counter becomes 0. Okay. So it's going to restart. But your global counter still has 2 in it. Okay. So when you go back, it again has 1. So your local count becomes 1 from 0, basically become 1. But global count maximum is 2. So because global count has 2 and local count has 1 in it. Okay. So basically you get 2. You continue forward, you actually loop through, you reach towards 2, local count is 2, and then ultimately local count becomes 3, and you do maximum of local count, which is 3, and global count, which is 2, so it becomes 3. And that's where loop ends, and you actually return um, Okay, you return basically that global count. I was waiting for this thing to sort of like disappear. Anyways, let's take a look at lab. So there is this website I want to actually tell you all about, and it's an online playground. So we can use this sometimes to basically um, see or basically conceptualize whatever we have conceptualized, write a program against it. So we're going to use this website. It's called repel.it languages Swift. So you just search for like online Swift compiler or online Swift IDE. You're gonna get a bunch of them. So use any of them. It doesn't matter. So let's write a function for this. So func max consec one. We're gonna take an array as an input, and this is going to be an int array, and we return integer count as the return type. Okay, now once again, we keep a local count and we keep a global count. Then we say we're going to iterate over each item in the array. Okay, while we're iterating over, we're going to say if the item is 1, then we're going to say local count is plus equal to 1. Okay, which is same as local count plus 1. Okay, and then you say global count is equal to max of local count and global count. If this is not the case, then reset the local count to be 0. Now, this is when I said, like, if the interviewer is asking you for counting maximum consecutive ones, and even if this is not a binary array, it has like any other value, it's not going to matter because we are not relying on comparing 0, we are just relying on comparing 1. Okay, so it's just the nature of the question that is, but like I just wanted to give you some examples of what kind of questions you can ask. Okay, so now here we are resetting our local count, and at the end of the array, we're simply going to return our global count. Okay, so now let's go ahead and test this with some input. So I'm going to say max consecutive ones. Um, and we're gonna say this is the array that we are looking for. So first, let's give it the one that we saw in the example. I'm gonna copy this one and let's run it. So you notice the output is 3. So maximum count, maximum number of ones we found is 3. And if we do just 2, for example, and run it again, then we're gonna get 2 for this one. And let's do all zeros. So, okay. And let's do one more, all ones. There we go. So this is another thing. Once you have the solution, you want to make sure that you run by giving it a bunch of different inputs, and to test your algorithm by generating output by walking how it's actually working, and generating the sample output to basically show the correctness of your algorithm. Okay. And by the way, this is how you find bugs or edge cases in your algorithm by walking through multiple different examples. That's why we actually chose less number of items, all zeros, all ones, and stuff like that. Okay, let's talk about time complexity. So time complexity in this case is basically, let's count it. So we're gonna have one time. So this particular line is always gonna execute one time. This one is also going to execute at one time. For loop is going to be executed n times. So number of items there are, it's going to be executed that many times. All these other things are going to be again n as well, right? And because they are inside the loop, and this is going to be one time. Okay, so if you add all these values, so all these number of times these things are executing, so you just say 1 plus 1 plus n plus n plus n plus 1. That means um, 3 plus 3n. If you look at this number for larger input value, these 3 and 3 are not going to make much difference. So we're only going to choose the n. So that means solution, our solution's time complexity is O of n. Okay, so the as the input is going to grow, similarly the execution or the time complexity, time it takes to execute this particular function, is going to execute it. So it's O of one solution. Okay, so we're gonna try to do this for most of the algorithms, for most of the solutions that we find. But keep in mind, this is how you can basically get yourself more aware of time complexity by doing this thing at the end of every algorithm that you have devised, because your interviewer is gonna be asking you these questions. So, okay. So hope this gives you a good enough idea. And in the next video, we're gonna take a look at another example of doing something uh, with solving another problem, another real interview question. Okay, so thanks again for watching, and I'll see you guys in the next video.